RPMs and get into a torque curve at very high RPMs. And that's why the Wenco is really not an efficient engine. The best engine in the world, which I believe the Jones engine is the best engine, is an engine that conceptually is the best engine from the foundation. And so the Jones engine has the best lever distance. We'll go into the combustion chamber and talk about that and see if there's any other advantages. But it's no mystery that if you could take an engine like the Jones engine, apply forces perpendicular to the crankshaft, and you can geometrically figure out how to operate the engine so it will run correctly, you have the best engine in the world. That's really what I've done. I've developed the best engine in the world because I've taken those forces and I figured out something nobody else has figured out, how to geometrically achieve operate an engine, an internal combustion engine, get all the cycles, and to be able to do everything necessary to run the engine efficiently with perpendicular forces, one-to-one with the crankshaft throughout the RPM range. No other engine has ever done that. That's why this lonely inventor has come up with an engine better than all the other engines. If somebody would have taken the forces and applied them perpendicular and figured it out, they would have the best engine. What's the next best engine of the benefit of the Jones engine? The best combustion chamber is a chamber that will take fuel and oxygen, compress it, and when it explodes, it doesn't lose all the explosion through the loss through the rings or anywhere else. You want an explosion that harnesses all of the energy so that it can be applied to something, the crankshaft. Well, the best combustion chambers are the ones we currently use. They're round, they have valves, and these are still, for 130 years, the best combustion chambers. So we're copying off of the best combustion chambers. The only difference between the Jones engine and other combustion chambers is we even have a better combustion chamber. And I'll explain why. If you were to take fuel and oxygen and you mix them together, and you have a piston going up to a certain particular position. Now remember, this piston is attached to a connecting rod, which is attached to a crankshaft. And that crankshaft turns like this. When it gets to the top, that piston goes to a certain select position. It can't go any further because it's attached to the crankshaft. As it moves up, you have a spark, and it goes down, and it does its job. So you're compressing. It doesn't matter what kind of fuel. Whatever fuel's in there, you're compressing it to a certain point, then you're sparking it, then it goes down. You generate a certain mean effective pressure out of that cylinder from that fuel and oxygen. With the Jones engine, we can do that too. We can operate it to a certain level, spark it, and create a force at a level of a mean effective pressure of our liking. Whatever the computer tells it to create, it will create. However, if we have the same amount of fuel, the same amount of oxygen, and we compress it further, and we don't spark it, we get what's called dynamic compression. And that means we compress the fuel and oxygen so tight that it heats up so much, it creates a spontaneous explosion, which generates a much larger force. That's why the diesel engine is so efficient, because it takes a fuel. It happens to be a heavier fuel with higher BTU content. And as you compress that fuel, it compresses it till it spontaneously ignites, and it creates a much larger force. And that larger force is what makes the diesel engine more efficient than our gas engines. It's got the same amount of fuel, albeit it's a heavier fuel with higher BTU content, but it presses it to the point where that fuel compresses and creates a larger explosion. That's why the diesel engines are heavier, because they have to be stronger engines to substantiate or to handle that type of a force. The Jones engine doesn't necessarily have to have that because it applies that force perpendicular to the crankshaft. So you don't have wild forces that you would in the diesel engine at the 12, 1 o'clock, 2 o'clock positions. You have the same forces around the engine at all times. So What's unique also about the Jones engine in a dynamic compression scenario is that you can mix any kind of fuel. Doesn't matter. Kerosene, diesel, natural gas, hydrogen, regular gas, anything, ethanol, whatever. In a spontaneous dynamic compression scenario, you compress the fuel until it explodes, and you get the most amount of energy out of that explosion. So not only does the Jones engine have the technical mechanical advantage over every other engine, it also has the best combustion chamber. So we're taking the same amount of fuel and creating the largest amount of force on a combustion that can be created from any kind of fuel. So we've got the most amount of force, the best lever distance. What else could be better? Well, there isn't anything even close to it, quite honestly, in the combustion engine market. But there is something better. We have an electromagnetic array. We're the only patented electromagnetic hybrid internal combustion engine in one application in the world that I know of. There may be new ones. They might be out there trying to copy this. But the fact is, we have an electromagnetic array around the engine, so it's both an internal combustion engine, the most theoretical, efficient internal combustion engine we could come up with the best electromagnetic array around the engine, so it's an electrical motor and a generator, all in every single Jones engine application. So you have the most efficient position for the electromagnetics to generate the most amount of torque, the most amount of force on the crankshaft, with the most amount of combustion forces from the fuel, giving you the perfect balance of an electromagnetic hybrid and internal combustion compression ignition engine on the crankshaft. And that's why the Jones engine is not only the best engine, it probably will never be, it'll be hard to ever beat the engine's idea in the future. It'll probably last well into many decades until we don't burn combustible fuels. Maybe they'll go to something else. But as long as we're still dealing with combustible fuels and we still have gas stations and we still have to do what we're doing, the Jones engine is going to be the best engine out there. There's another thing that is unique. When you burn a fuel like the Jones engine burns, you don't have the exhaust gases that you would have and the amount of wasted contamination that you get from the pollution that you get from other internal combustion engines. It burns more thoroughly. And it's very important to know that we could take ethanol, burn it in our engine, and get more force than our competitor in a diesel engine. We'll have higher torque and absolutely perfect emissions. So there's a lot of advantages that the Jones engine has that other engines simply don't have or can't compete. There's other things that need to be talked about. The Jones engine is lighter. It's got a better power to weight ratio. It's got it can be in any size, 4-cylinder. In a 4-stroke configuration, it has to be in 4s. So 4, 8, 12, 16-cylinder. In a 2-stroke configuration, it has to be in pairs, 2, 4, 6, 8. But also with the Jones engine, you have to understand, have you ever driven down the road in your car and let off the gas pedal? What happens? Your car slows down. Well, it's slowing down because the pistons are still burning and they're dragging that momentum. They're slowing you down because your momentum is faster than the pistons are going, and it's dragging you down and slowing you down. With the Jones engine, it isn't like that. The second you let go of the accelerator, you have an absolute freewheeling vehicle that has no restrictions and no friction on it. See, when our pistons explode, they're independent of the crankshaft. They ratchet the crankshaft. The second you shut off the fuel, the crankshaft still spins and the car still goes. So what do? We automatically brake to represent the same deceleration that your other cars achieve and do. And we take that energy and we put it into fast cycling batteries so that when we reaccelerate, we apply it to the electromagnetics in our engine, and speed right back up to the speed we need to go, and we continue to operate like that. You're getting all the energy you can possibly achieve out of braking back into the engine without having an elaborate separate electrical motor, separate internal combustion engine motor. It's all in one motor, one package that's smaller than a normal internal combustion engine. You have a better power to weight ratio, smaller engine, lighter weight. It's cheaper to manufacture. It's cheaper to warranty. It's easier to rebuild. There's no block in this engine. The entire engine can be rebuilt in 1 hour. Try to do that with a 4-cylinder engine. There's no water pump. There's no alternator. There's no starter. So you have less mechanics. It's oil and air cooled. So you have less moving parts. Because the power stroke is independent of the crankshaft, you can apply multiple engines in line attaching a common crankshaft, and you could have multiple engines on one crankshaft. So let's say you're in a military vehicle like a Hummer or an airplane or a helicopter. You could have 3 or 4 engines operating with all the flexibility in the world. Let's say you want to run one engine electromagnetically only. You could do that. You could run them all electromagnetically only with no compression at all. They can do that. You could run them without any electromagnetics and just run them as a compression internal combustion engine, and you could do that. You can pick and choose the power source you want from every vehicle, and because they're so lightweight and small, you can package them like that. So aircraft anymore, you don't need multiple engines on the wings. Everything's inline. We have less air restriction, and you run all the engines inline right off the center of the fuselage and run as many engines as you want, and you're as secure as you can be. So the engine is very, very unique in that it can run off of a common crankshaft either electromagnetically, as an electrical motor, or as an internal combustion engine, or as both. So you have all the safety features. If you run out of gas, you won't stop the engine. In military applications, you have to understand internal combustion engines are susceptible to a variety of abuses in a military environment. With the Jones engine, you could have a common engine, say a 200 horsepower, 600 foot-pound torque engine that would run in a Hummer. Well, if you want more power, you just put 2 engines in that Hummer. If you want more power from another vehicle, you just bank the engines. You have the same common parts. They can be replaced right in the field. You don't have the problems. Any fuel available, put it in the engine. You could run diesel fuel and chase it with regular gasoline and then chase it with ethanol, and it'll still run. You can mix them all together. It'll still run. And so the Jones engine is very, very flexible and very valuable to the military because it can do so many things other engines simply can't. When you can generate so much torque with the Jones engine, you replace all kinds of engines. Not really all kinds. You replace every engine. Every engine, internal combustion engine above 10 horsepower will be replaced by the Jones engine. And when it comes to turbine engines, you get some benefits.